Assalamualaikum warahmatullahi wabarakatuh and good day to each and everyone. So, once again, this is EA224, electronic circuit device and or electronic device and circuit analysis. Okay, so last meeting we have already discussed the basic concept of diode, how does it operate, and the basic materials that can be used in order to formulate the diode, okay, certain diode. So now we will be going through deep inside about the application of the diode, its characteristic and its basic application. Okay, so we have going to discuss the load line analysis. Okay, this is inside of load, when there is a load, okay, that is being connected in the diode. So we also have here how to determine the Q point of a system. We have also here the diode in DC series circuit, and we also have here the series and parallel configuration. So sa last meeting kasi we have just discussed the basic application, and we have not yet um, discussed how does it apply in every phenomenon, okay, that we have now. So okay, so let's go on. So we have here the load line analysis. So ito actually yung pinaka basic niya graph, okay, for the diode to be operated. So as you can see here, we have here the characteristic device, no? This blue graph here will be the characteristic operation of the certain diode, and this line here is called as a uh, load line network. Okay, so basically this is being formulated when there is a different types of diode that is graphed together in order to have this. Okay, sabi dito, the load line path, away, the load line plots all possible current IP, okay, condition for all voltages applied to the diode VP or V sub O, no? So, in a given circuit, ER is the maximum ID and E is the maximum VD. Okay, so this load line here is the possible plot of all possible current, no? So, when you plot all the possible current, um, ID, okay, ID pala yun siya, not I sub O, ID. When you plot that all possible current and connect them at once, so you can formulate this load line here. Okay, the condition for all voltage applied to to the diode, no? So kumbaga ito siya kay we are having a um, data point, no, na certain data points that have to be connected at all to formulate this load line. Okay, so in a given circuit ER, okay, E over R, that is the maximum current and is the maximum voltage. So where the load line and the characteristic curve intersect is the Q point, which specifies the particular current and voltage for a given circuit. Okay, so this load line here intersect with the characteristic line or characteristic graph of a certain diode. Okay, the point that intersect them is tinatawag natin Q point, where that Q point is dyan natin makukuha yung certain current and voltage, okay, that the diode operates with, no? So when a diode operates at a certain load line and at a certain characteristic graph, okay, that two graph will intersect each other, and the Q point that and the intersection point is called as a Q point, and corresponding to the to a certain current and voltage, no, that defines the operation of a certain diode. So as you can see here, this graph is a graph of a voltage versus current. Okay, so yun. Now, how to determine the Q point of a system? So we have here a different or step-by-step method on how to define a Q point of the system. So the first one is identify the diode model. Okay, so you have to identify the diode model. It's because for you to be able to have this graph here, no? Itong characteristic equation. So usually kahit given to siya. Okay, so for you to be able to find the Q point, okay, to have the intersection of this characteristic line here or load line here and this characteristic of the diode. Okay, so uh, you need the model, okay, model of the diode that you are using. Okay, then after that, no, after you identify the model and you identify this graph characteristic graph here, the second uh, the second uh, will be identifying the parameters using the Kirchhoff law. Okay, so it's either you use a KCL or KVL that we have already um, understood from our previous subject in Physics 41, or in our physics is Physics 221. Okay, um, okay, so we have already introduced that one. So using Kirchhoff's law, we have set voltage at the diode should be equals to zero, no? So it means that we have first to set that one to equals to zero, which will be the horizontal line. Okay, so dito yan siya, horizontal line. And then we also set the current of the diode should be equals to zero, which will be the vertical line. Okay, then obtain Q point, PDQ, and DQ from the graph of intersection of Q. So it means that if you have now this equation of this one, of this Kirchhoff voltage law here, set the VD is equal to 0 and set ID is equal to 0 to for you to be able to find this intersection of the load line here, no? Just as what we have learned from our basic algebra, na kung meron ka ng equation dito, so kukunin mo yung intersection ng load line na yan sa x axis or y axis, so you will just have to set that one is equal to 0 for you to be able to have the intersection. Okay, then after that, no, after mo ma-set itong VT is equal to 0 and ID is equal to 0, makuha mo na tong kuan na to, graph na to, so you will find the intersection of the characteristic graph and the load line, and then you will now find the value of IDQ and VDQ. Okay? So, yun. So, ganun lang actually kadali, no? Um, Once again, the first step is you will identify the model of the diode that you are using, no? For you to be able to find this characteristic graph. And then, by using Kirchhoff's voltage law, no? Or KVL here, okay, the you can identify the kuan, what do you call this one, you can identify the equation that defines this that defines this circuit here, no? So then after that, para makuha mo na yung linear equation na yun, set VD is equals to 0. Okay, so what is the value of ID, no? So yun yung intersection niya along the ID axis. Then set ID is equals to 0 naman, then what is the value of VD? So yung value na yun, kaya yun yung intersection ng load line dito sa VD axis. Then connect that two point that you have find. Then kung ano yung intersection niya dito sa characteristic equation, doon nakatapat yung ating voltage sa current and the current, I mean voltage sa diode and current sa diode. Okay, so yun, ganun lang actually kasimple. Okay, so we have here the diode approximation. Usually, we are using this one. Okay, this approximation here. So approximation model notation. So in forward bias, it means that this one, no, forward bias to kasi yung positive ng diode natin is naka-connected sa source, and then yung kanyang negative is naka-connected sa resistor. So that is forward bias. So usually we are using voltage across the diode is equals to 0.7 volt for silicon diode, and we are assuming that it is equals to 0.3 for germanium diode. Okay, so usually yun yung nakukuha natin dito sa voltage na to if we perform these steps here. And then for the reverse bias naman, we know that pag reverse bias kay walang voltage dito, so ibig sabihin this one is naka-open circuited siya. as we have just said from our previous discussion. So VD is equals to source voltage, okay, and ID is equals to 0 ampere, no? So ibig sabihin um, walang dumadaan dito na current kasi nga naka-open circuited siya. Okay, so yun. So we have here an ideal model notation. So we have for VD is equals to 0 and ID is equals to 0. So dito natin binibase yung ating load line analysis. Okay? So here, no, we have here this certain certain um, method on how to calculate the certain parameter of a certain diode connection. So we have here diode in DC series circuit. So assuming that it is forward bias, so the positive of diode is connected on the source voltage and the negative of one is connected to the resistor. So if you perform a KVL here, so what we'll do is VR, no, VR is the voltage across T1 is equals to E, then minus VD. Okay, then, but we know that since VD, we are using the approximation, VD is equals to 0.7 volt, or in germanium, that is equals to, that is approximately less than 0.7 volt, as we have just assumed here, this is 0.3, then substitute the values, we will find the ID, okay, on IR. So now, and then for the reverse bias naman, we know that for reverse bias ang ating current kay 0, no? As I have said, then yung VR natin is also 0, no? Since wala namang dumadaan dito na current, so therefore, there will no be a voltage drop across this resistor. So ibig sabihin, lahat ng source voltage natin is across on this diode pag reverse bias siya. Okay? So take note of that. So, sabi dito, an open circuit can have any voltage across its terminals but the current is always 0. So, pag yung circuit mo kay open circuited siya, so that's like what we have here when the diode is reverse bias, magiging open circuited to. So, wala nang dadaan dito na current. Okay? But the voltage is can have any value depending on what is the value of the source voltage. Okay? So it means that whatever the value of the source voltage, pag open circuited siya, so that is also the voltage across the diode. Okay? So a short circuit was 0 voltage drop across its terminal, but the current is limited only by a surrounding network. So approximately when the diode is in forward bias, we approximately assume that this is equals to 0. No, the voltage across this diode is equals to 0. So the current is maximum, no? So the current will go through this resistor, okay? And uh, well, this resistor will have a voltage drop. Okay, that is the approximation. So we have here the source notation, no? So if you will see this, kindly apply this notation here. Okay. Now, we have here an example, so please study this certain examples. This just suggests what I have said kanina dito, no, in order to find the characteristic graph and the load line analysis in order to have the Q point of a certain graph. Okay, so please study this example. Okay, so we also have an example here on how to find the on how to determine the certain current and voltage of across the diode. So please study this also. So once again, no, okay, so we will be go through this series in parallel connection. Okay, so okay, actually these are just the same as what we have just done. No? So as for summary, no, as for summary, as for summary, um, the voltage, as for the summary, once again, the voltage, pag ang condition natin kay forward bias, pag ang condition natin kay forward bias, ibig sabihin, the positive, uh, the positive uh, terminal here is connected to the source voltage and its negative terminal is connected to the resistor. Ibig sabihin forward bias na yun siya. So ang function, ang ideal function or ideal model ng ating diode is short circuited. So ibig sabihin the current is maximum and the voltage is approximately equal to 0. Okay? Or in the or in the silicon diode, that is equals to 0.7, and in germanium that is equals to 0.3 volts. Okay? Pero pag reverse bias siya, so ibig sabihin yung positive or yung negative na terminal ng ating diode is connected on the source. Ibig sabihin reverse bias siya. So the diode will perform as a open circuited. So ibig sabihin ito siya kay walang dadaan dito na current. Only the voltage, okay, will be across to this one. Okay? So yun. So ganun lang actually. That's why in the application they call diode as a switch, no. They assume, or they um assume that the diode functions like a switch, no, because of its capability of capability of um, um, having a diode same as open circuited when it is forward bias, and short circuited short circuited when it is forward bias, and open circuited when it is reverse bias. Okay, so if you have again a question regarding on this discussion, kindly kindly ask it to me right away. Okay, so please ask it to me directly, no, so para wala tayong magiging problema. So I think that's all for this discussion. um, um, so next, inshallah, we'll be having our exam, no, so please update, no, keep updated. So that's all. Assalamu alaikum warahmatullahi wabarakatuh.